Hello, I hope you guys are doing amazing. So, one of my friend asked me to make a video on this problem. This is a lead code question number 80, and it says remove duplicate from sorted array 2. Okay, this is a category of medium, so it's a little bit tricky. So let's see how we're gonna resolve this problem with the space complexity O(n) and time complexity is O(n). And so let's go through the problem. What exactly is the ask here? So we have given an integer of array sorted in non-decreasing order. Remove some duplicate in place such that each unique element appears at most twice. All right. The relative order of the elements should be kept the same. Since it is impossible to change the length of the array in some languages, you must instead have the result be placed in the first part of the array nums. More formally, if there are k elements after removing the duplicates, then the first k elements of nums should hold the final result. It does not matter what you leave beyond the first k elements. Return k after placing the final results in the first k slot of the nums. Do not allocate extra space for another array. You must do this by modifying the input array in place with O(1) extra memory. All right, so see, there are so many information already in this description. So first thing you have to see that this one is, we have been given a sorted array, and this is sorted in non-decreasing order. Okay, and we have to remove some duplicates in place, not all of them, but some. And each unique element appears at most twice. So if we look at the example number one, we have been given 1, 1, 1, 2, 2, 3, and we have to make we have to arrange it in such a way that the array will be 1, 1, 2, 2, 3, and we just need to return the length of uh, those once we modify the array in the given order, right? Like at most we can keep the duplicate, but it should not uh, exceed than two, number of two elements. So, and the custom judge, right? We have been given integer input array, expected numbers, the expected answers with correct length. So the k length is the length which has the array in the same order. That means a non-decreasing order, and it will contain the element at most two times of the duplicate if there any. Okay, so let's see how, as you can see, this question is given as a sorted array, and we have to do the modification in place. So uh, this is very much qualified for using the two-pointer techniques. And let's see how we're gonna apply the two-pointer techniques to solve this. So we have an array with 7 elements. The first 3 elements are 1, followed by 2, and the last 3 elements are 3. And once we pass this array to our algorithm, it will convert this particular one to the new array that will contain 1, 1, 2, 3, and 3. Okay, so that is the end goal, right? And we all we have to do is do we just need to return the length of the the array for till where we just did the modifications. We have to remember that we are not allowed to create another array. We don't, we just need to do this all operations in place, right? We can modify the existing array. We are not allowed to use an extra memory, simple, right? And as you can see, this array is sorted, already given. So this, and we are doing this operations in place. So this problem is qualified to use the two-pointer technique, which we have discussed uh, a few days back. And so basically, for two-pointer techniques, what we need to do, we need the two-pointer. And since we are going to modify this, right, we also need to make sure that, like, there are two things. Like, number one, we are allowed to have the duplicate, but the only up to two, right? So two. If the count of the element is less than or equal to 2, we are good. Like, we are allowed to have it. Else, if it is greater than 2, we should remove that. Now, as you can see, so we do need a variable count. We can say count that is going to keep track of the how many elements we have been reading so far. And we do need the two pointers. So I would say the pointer one would be my, let's say I will call it the right index. Okay. So right index, and the pointer two, I would say read index. Now, what we're gonna do is we have to iterate through this array, okay, from 0 to length and whatever it is, okay, and we need to move it one by one, and we need to make sure the count of the element is not exceeded than 2, okay. So basically we have to compare these numbers, right, this each adjacent numbers. So to do that, what we can do is we can initialize both the pointers at location 1. Okay, so my write and my read index are pointing to the first elements, that is index, both are equal to 1. Okay, and then when I started my loop, I'm going to compare this with my previous index value, and if it is same, we're gonna increase the count. So initially we will have our variable count, which is going to be 1, and as soon as we see this is equal, we're gonna increase the count with, we're gonna increment it by 1, and we're gonna keep continue the next one. And here, when we come, we will see that this element is again equal with the previous index value. In that case, we will see the count. We also increase the count. Okay, it's gonna be from 2 to it's gonna be 3. Now we have a problem, right? Because it's 3, then we need to replace this one. And since we counted, what we're gonna do, we have to remove this element, this particular, and move the element 2 to here. Yeah, and we can simply update the value right from the previous index. Now, if we so that's the idea we have to follow, right? We are moving two pointers in the same direction. This is the example of moving the two pointer into the same direction, and we are initializing at one place, and we are comparing it with the one minus like the previous one, for example this one. So what we can do is we can compare this. If it is same, we're just gonna keep updating the values. All right, if it's the same and the count is less than or equal to 2, we're gonna move these values here. Once we count the 3, the count is greater than 2, that means we have to move our read index to the next one and update the value here, right? So let's see how we're gonna uh, do that using the Java. Okay, so as we discussed, to implement the algorithms, we need a variable that will keep track of the how many elements we have placed so far. It should not be greater than 2. So we can call it a counter that is going to be initialized to 1. And we also need two pointers. So you can name it anything. So I will say write idx, that is going to be 1, and my read idx is also going to be 1, right? Now that's three things we need, right? So the space is constant. We are not going to use any more variables or any new array, right? So we defined the arrays, uh, sorry, two pointers and the counters. And now we're gonna iterate through the array. For that, we're gonna use the for loop, and that's gonna start with my I that is equal to the read index, and we're gonna keep going till the length, and we'll say I plus plus, and what we're gonna do is we have to see, as we're discussing in the pictorial view, right? We're gonna compare the existing with the previous, the current element with the previous element. If it is equal, then we're gonna increase the count. So we're gonna say if nums I equal to nums I minus 1, and if it is, simply increment the count, my counter. Else we're gonna reset the counters to 1. That Now why we are doing this? Okay, because we are not if my current value is not equal to the previous one, that means we found the different value. Okay, it's a different element than the previous one, so we have to reset the counter and start the counter for this new values going forward. Okay, that's done, right? That's the counters will take place, right? If it is now, if the value is same, we are increasing the counter. If the value is different, we are resetting the counter to 1. Now, one more thing we need to do, if my counter's value is greater than or equal to 2, then we are good. We need to make sure that um, we are updating, we are moving our right index, right? So simply we are going to update the values at the writer index with the value at I, and that should be it. Like now, this will keep moving my index, right? If my value is greater than or equal to 2, we are moving. And if it is the counter is greater than 2, we are not moving the write index. We are only moving the read index, right? So read index, which is I, initialized with I, and that's all we are doing, right? So we are skipping it. We are skipping it. And the new element, whenever it encounters, and if the value is less than the counter value is less than R2, then we are going to write to the index where our write index was. So that will do the trick. And once we are done with this loop, we simply return the write index. That's it. Like that will take care of the the issue. So let's try to run and see how it works. And you can see the result is as expected. Awesome. So as you can see in the given example, right, we only define the three variables, two pointers and the counter variables to keep track of the element should not exceed more than 2, right? And then the problems is very simple. We did all the operation in place. If the counter is 2, then only we are moving the write index. Our read index is moving in the iterations, right? This is simple, right? Either we can do this or we can just replace the I with the read index. It's absolutely fine. And it's still, right? So only the read index is moving forward. If the count up to 2, we are writing it and then we are skipping it. So the space complexity is O1, it's constant, and the time complexity is O(n). So you can see that the two pointers technique is very efficient, and this is one of the example where we initialize the two pointers and the at the same in the beginning, and we are moving both the pointers in the same direction. Okay, thank you so much.